Good day, gentle readers, fellow earthlings. Welcome to another episode of Logos 2000, 21st Century Foundations, from a desk with Ross Finlayson, this breezy December 26th, 2024. Happy holidays. As well, today, there's not so much of a particular subject or topic today. The last episode was kind of the similar course, and the ones before that had a focus on the continuous and the infinite, where the idea is that after that there's a natural infinity and natural continuity, that these exist in the theory and for a strong mathematical platonism, yet it as well relate to what are all our inductive and classical accounts that make for otherwise the paradoxes of infinity and continuity, that Zeno is given to not bring paradoxes but not paradoxes. These things that are not apeiron, that do have resolutions according to deductive analysis, and they exist. Because otherwise, if mathematical logic is full of intractable, unsoluble, contradictory propositions, then it would be just of no thorough reason and rationality. So trying to address how the superclassical then, which is basically just means if it's infinite or if it's continuous, and if it's truly or absolutely infinite and truly continuous, has that then the idea of these natural infinities and natural continuities are kind of made for that there's at least three kinds of continuity and at least three kinds of infinity naturally, or from axiomless deduction, axiomless natural deduction, a theory from nothing, as for the fundamental question of metaphysics given an answer. That is, of course, by no means the novel and something that nobody ever tried to figure out before. Instead, it's always just kind of been arrived at, that it just kind of keeps getting tossed back and turned over, when instead it's something that should be understood as for itself what it is, the reasoning to make for an axiomless natural geometry after this axiomless natural deduction. And then to have that related to, from the quantification and comprehension over words, for the infinity, so that then there's this continuity and there's infinity, and they go together, and they're the objects of mathematics this way. So why this isn't already the case is because the developments usually stop short of saying that can be a thing. And for our phenomenological and scientisms, logicist positivism, you have to have something that's relatable and relates. The idea is that for phenomenology, we have an object sense, includes a continuum sense, and a sense of time, and a word sense, and a number sense, and in this object sense. And then the infinity is basically, after the sense of the continuum, the sense of numbers. And so that there are infinite numbers in continuous time. That's the sense of the object, the thing in itself, the thing. So that this way, with that being kind of the merest account, as it's called, the briefest, the least kind of account, it still arrives that this teleology has this connection of things, and that continuity and infinity are actual instead of merely potential. And so that then for these inductive impasses that balk, that quit, that instead there are these analytical bridges which make for these complementary duals that attain to each other, that there are completions and reach to each other. Now, of course, mathematics has this as part and parcel of the entire consideration of the real numbers and the standard linear curriculum and real analysis, and also as with regards to the continuous everything in continuity and discontinuities. and all such manners of relation about the continuous manifold, which in all the usual theories of physics, the space and space and time are given to be a continuous manifold. So with that said, then it's kind of relevant to have then at least an account where it's intersubjective and interobjective. This strong mathematical platonism survives in a world of otherwise weak logicist positivism. That's the way to make a stronger logicist positivism, because then what arises according to the words is also justified as existent mathematically. So that's among the reasons why then it's considered necessary. Then that as well, these at least three replete notions of continuity, three laws of large numbers, three different kinds at least, make for that. Otherwise, the one that's given in its inductive accounts excludes and forbids the other ones, which either way would be perfectly suitable on their own. And that makes for a broken or incomplete, a partial, at best a half of mathematics. And one, when talking about foundations, it would not be conscientious to say applies. And so then what there is then with regards to the ordinary and the cardinal, this extraordinary and the super cardinal makes for them all being together in a theory without any mathematical paradoxes at all. That's yet complete and consistent. So that it's consistent, no paradoxes, and complete, nothing missing from it. Because to say it's a theory of all the things when it's not complete would be a contradiction. So there are no paradoxes in this manner, and no logical and mathematical paradoxes. They're solved via these various superclassical notions, so that Zeno and the classical exposition is the superclassical, or motion, according to the infinite divisibility of time, is not paradoxes, and just illustrate the sensibility and necessity of deductive inference to arrive at where inductive inference would fail. Yet that's what it is about. Of course, just reading Aristotle about Zeno, you can find both of these accounts. He makes constructively either way what should meet in the middle. And then as with regards to the principle of contradiction, here that is framed instead as a principle of inverse, then we can make all later what includes all these principles of conservation in physics, is principles of continuity. It's not broken, and it's not incomplete. And then furthermore, saying it's so about it's the comprehension and quantification over the domain of discourse and the realm of thought, has that it would be unconscientious to say that it's consistent if part of that is that it attains to be complete and is not fully complete. So the completions here in the analysis, the completions are that a limit exists, and the limit is no different than the sum. In the inductive account, that has to be walked back and said, well, what we mean is that you can get close enough. But what that means is that's not close enough, because it's only perfect in the limit. And then also, when you consider that from either side of the limit, it's either continuous or it's not. And if it's only close enough, it's not. So it's necessary to have this account for completions that are true in the infinite. Then for these great cases where it's like, this convergence criteria is kind of good for our naive law of small numbers, that's our law of large numbers. Other times it fails. This is mathematics' issues and problems about convergence and emergence. And then luckily we have both various notions of large numbers and what happens for asymptotics in actual large numbers. And then also all sorts of approaches from the empirical that would be non-standard, like Dirac's delta function as giving a means of the applied for so many things. Or the non-standard improbability distribution, something to explain why otherwise some of these things that have a one-sided halfway close approach have completions to fill out the other side. That then there's also emergence, and really here it's for Vitali and Hausdorff making for measure theory, because everything for analysis has to end up having a way to add it back up. it has to be able to add back up. It has to be able to have a way to decompose it and recompose it. That for the accounts of equi-decomposability, that being the fundamental statement of measure theory, pretty much, that measure is an invariant, measure is a constant, and for things that are conserved and in the sense, and is about symmetries and about continuity, and geometry, the world measure, that thusly measure theory and the quasi-invariant measure theory and differential analysis and the pseudo-differential analysis and these kinds of approaches help to explain what happens in these continuum mechanics when Vitali and Hausdorff make for doubling measures and halving measures. And later von Neumann gets all about that in the plane, and later Banach and Tarski write up a great algebraic approach, what belongs originally to Vitali and Hausdorff, and the geometric approach for the three-dimensional. So that in the one-dimensional it's pretty limited and simple, and in the two-dimensional it kind of starts breaking open, and three-dimensional it kind of falls back in. These doubling spaces and doubling measures and halving spaces and halving measures, about the quasi-invariant measure theory, about Ramsey theory, and otherwise about actual infinity when there is more than one law of large numbers, and it's not always the same outcome for things that are actually infinite. That thusly, that was kind of that's pretty much the entire consideration here of the foundations, is that is foundations. I want to learn mathematics and just understand the discrete and understand the continuous, and that it's one theory, so it must kind of be so. The standard linear curriculum is great, and the means of there's a course called pre-calculus usually, and it just helps to define the limit, the infinite limit. And so it's something that's so, and it's only so in the unbounded, and it helps to differentiate a particular, or rather to delineate a particular domain of discourse where there's not necessarily the infinite, but there are bounds, and then is the unbounded. Then whether that's actual or potential, here has that it's potentially actual, the unbounded. And so in pre-calculus, the idea is to learn that there's the limit has its definition to exist, and that over time, kind of like function theory and topology here have been shown to have their definitions kind of grow over time to take in more and more kinds of mathematical objects. Then as well, the limit is kind of like so, where at the same time its first purpose is to kind of restrict to a particular kind of mathematical object when it's otherwise any kind of infinitary expression at all. Any kind of expression with unboundedly many or infinitely many terms in it to make one expression a value at all. So then once that's given, the definition of limit, then for delta-epsilonics, because the proofs are just made in terms of like looking at from any positive number at zero, then like delta is a small difference and epsilon is less than it. And so there's just frames a bunch of different forwardly inductive theorems why it goes to zero and why it's no different from zero in the limit, the delta-epsilonics. Then that's used to build for Riemann sums, and after the fundamental theorem of the derivative, and then the fundamental theorem of the integral, how to arrive at the derivations for calculus. And not just the rules of calculus, like here's the power rule, here's the rules that happen to be given for trigonometric functions, here's the rules about composing and substitution and the chain rule, and otherwise with regards to treating variables and doing the bookkeeping, the rules of calculus. But the derivations that arrive at those rules have any justification at all is from these simpler principles, and so given. And that's great, and that's a standard linear curriculum. And so the only reason, or among the only reasons that it's necessary to say that that's not complete for itself is that continuity is replete and infinity is replete in its ways about counting numbers and ordinal numbers and the integers, and then for these line reals, field reals, and signal reals. each constructively built themselves, just like delta-epsilonics makes for field reals to begin, then there's as well a way to make for line reals constructively and a way to make for signal reals constructively. That then in the greater account of like the idea of that, well, then we're just dealing with a theory with only one relation called set theory, and then we have axiomatic set theory and then descriptive set theory. Then as is described here, it's like, well, there's natural infinities that set theory has to understand to bring into account. And then there's these natural continuities that analysis has to understand to bring into account. Because otherwise they will contradict each other. They will contradict each other, and then there's no good theory. So that's just among reasons why here that that's one of the most usual things. So that said, and you can find it that's largely this has been my understanding of these things for at least since before I started recording podcasts here for the past couple of years at all. So yeah, for 15 or 20 or 30 years, I've had these ideas that these are facts of mathematics, and I've built the derivations necessary for things like the line reals to be so constructively demonstrated. And so I can point to in works like Aristotle where it's not so different at all, and it can arrive at the same thing from the same principles, except even from underneath that then, that I've been thinking that the theory is axiomless natural deduction since at least 20 years ago or so, and that there's natural infinities more than one kind, natural scalar infinities for at least 20 or 25 years or so. Or at least according to my tens of thousands of essays I've written up some of these Usenet news groups for all these times. Just to go to show that would be implicit in all these podcasts. Always haven't been so. Well, let's see what we have here today. Well, there's Derrida and Husserl. This is the origins of geometry, origin of geometry. Edmund Husserl's Origin of Geometry, an introduction by Jacques Derrida. And as we've been looking at this from before we kind of got into the natural infinities and natural continuities in this Logos 2000, is that there's been several times we've been able to find something good from Derrida and Husserl together, because in their discourse it's about the logicist positivism. And so, in a sense, when we were talking about weaker logicist positivism or stronger logicist positivism, in a sense, for logicist positivism, that's the only theory that there can be and that there is and that they have. And so, and it can also be related very strongly to science and a philosophically conscientious, if detached from a teleology, a science. So science and its theory can be logicist positivism, and the theories involved need not be any more than closed categories. They need not be any more than a theory that a stoplight goes green, yellow, red, green, yellow, red. And it need not be any more than a finite state machine, this theory of these things and the models of it. That then the philosophy of science can be applied, and you could say that, well, according to my philosophy of science and my philosophy of logicism, that my model is logical and consistent and about its completeness and its constancy and its concreteness, that it's a modality, it's got that it's modal, and so that the logic is relevant and modal, the logicist. And then for positivism, that the model is like this theory has these principles, laws, rules, axioms, those being all about the same thing. Those being the statements that affect to relate logically any of the terms or the elements which can be defined. That it can introduce elements and definitions and define their relations and define their relations and define their relations. That positivism is having a theory and having a fixed theory. So of course, as soon as you have one of those, then you can have 2 or 10 or however many you want. Each one of the possible combinations is its own. And then according to the data in science, there's the idea that things are reproducible, observable, and falsifiable. Then you can have any of those theories as just an abstract theory, and then ones that are scientifically not falsified are the ones that survive or are not struck or eliminated after that there is any of the data, that according to the data, the terms, and what's received as those is the phenomenological sense, that what's received of those can be interpreted as an observation and made into the models according to these definitions. Why logicist positivism is so great. It's a way to pick up and put down theories of any particular sort and to help organize them according to these kind of principles and maxims of a theory and of thinking about a theory. That the idea is that logicist positivism kind of arrives from axiomless natural deduction as well, as its own thing about the principle of sufficient reason. Yet that here, though, it makes for that at least any weaker or stronger logicist positivism can be contained in this sort of theory of philosophy of science. And then as with regards to that, including a model of the unscientific, that's as well possible with logicist positivism. But the theory itself is kind of shrunk, at least the weaker form is shrunk, because it's only completely that its first principles are the axioms of the putative theory, and its final cause is that actually it's always interpreted in the meta theory of science, and so it's only through the lens. This logicist positivism, this scientism, compared to the ones where as those grow, as the wider theory grows, it has to include everything around it. So weaker logicist positivism can kind of pick up and put down any theory, but it's always possible to take somebody's account of that and put it in a box of science. So that and to put it in and put every other theory in there as well is the idea. And then some will account for that. Well, there's one where that's not so, but you can always point out to them, it's like, well, that's missing at least one of these other parts, and so it's incomplete. And so with regards to your entire justification of the enterprise, it's not so, is a usual way of going to that. Then if it just ends up being that by an inductive account, it's like, see rule one is I am right. It's like, okay, that's a good theory. It's closed, it's consistent, it's complete, it's constant. It means zero, or it's just kind of one of those things that at the same time, most people's psychology and philosophy is like, includes being usually right. I mean, just not being entirely mistaken about the entire enterprise. But thinking about things and being conscientious includes that it could all just be immaterial. And that's about objectivity and subjectivity. And then the theory of mind usually has at least two ways of looking at it. So just in some of the popular psychology, you'll see some people say this like, well, that's when people don't think about other people or they don't think about themselves or one or the other. But another way of looking at theory of mind is having an individuality and having a personality and being a person. So everybody's got a theory of mind in that sense. And then as with regards to not necessarily believing what other people say, is that's fine. There's cynicism and skepticism, where cynicism is at least saying I formally and fundamentally at least have a nominal non-zero doubt of anything. And if that's skepticism, then cynicism is believing that most things are wrong, so that as with regards to any points of view or perspectives or matters of fact and these kinds of things. That it just kind of speaks well to this one saying, and it's from the Japanese originally, and it says, if you believe everything you read, maybe you shouldn't. And maybe it means maybe you shouldn't read, because what you're reading, if you can't tell the difference between good and bad food, you're going to be better off with that. And the other one says, if you believe it, then maybe instead what's best is to establish your own kind of filter between anything that's read, as in the textual sense, and then count that anything that comes in through the senses is automatically put through the forebrain, where the idea is that besides stimulus and response, and the carrot and the stick and these other such matters of displeasure and fear, or pleasure and fear, that it's possible to always kind of have that so in front as well. So being a skeptic is kind of well advised, yet at the same time, when there's enough established of what is so and what isn't not so, that one's theory is, after a while, what ends up not being eliminated is enduring. The idea is to find these enduring theories that hold true, hold good, that are good theories, and that then the rules are exceptions instead, and exceptions are rules instead, so that it's possible to have not necessarily a skeptical view while still not being a naif or easily fooled. Is most people's practical usual idea of having a theory at all. I would imagine vis-a-vis the desperate and these kinds of things, which start polarizing things and making for opposites and extremes and bad decisions is the usual idea. Yet desperate, in desperation, these kinds of things. So for the ultimate, and then like a theory of mind and objectivity and inter-objectivity, that's definitely the course of the idea for these kinds of philosophers. Because what Derrida and Husserl are talking about here is like, well, we're conscientious logicists, positivists, and so we all agree inter-subjectivity and all agree intersubjectively that this can be so for us, and we can call it true in the senses of this definitions of correspondence and coherence and pragmatism and what's fallibilism and according to nominalism and fictionalism, when we're not trying to say that it's absolutely true, yet, and because it's science and as well it's intersubjective, that is as well for their, what is their mathematical Platonism, or otherwise whether geometry, that the geometry kind of is given in this kind of account to arrive at is like, no matter what we say, perfect circle is a perfect circle, and the ratio of a circle's circumference to diameter is pi. And so trying to then relate that for a weaker form of logicist positivism and a briefer and a more contained, self-contained definition of logicist positivism, any theory of anything at all, or any model of anything at all, that it doesn't have to be an entire theory, it can just be like a model of a finite state machine. For logicist positivism to concur that its definition is so for closed categories, that here these authors early in the 20th century and to establish for the course of the reasoning about it and all it goes into, the thousands and thousands of philosophers that refer to Derrida and Husserl for all these different kinds of matters affected the course. That here it's a structuralist course, and then it's really just trying to figure out where geometry would fit and why that always makes kind of like a bulwark, a promontory of the stronger logicist positivism, which is also a mathematical Platonism, and its rules for the logic and mathematics as being Platonistic and existing, or as merely in our object sense, the perfect circle and the straight line, to have those then exist in this theory is like so. So in this sense, both Derrida and Husserl make room and give that, you know, Plato is an ideal thinker who has these as so. And so when somebody needs somebody to be able to say, well, somebody else at least also thinks this is so, that we don't just say it's like the angels or the aliens, we just say it's Plato. And then everybody in the world who studies these things knows that as so. And then in regards to like thinkers like Augustine and the medieval theologians of the doctors of the canon of this philosophy with its relations to the matters of fact, that it's like so. And at the end of, after German idealism, after Heidegger and then Gadamer, it's also like so. Amicus Plato. If you want somebody to blame for mathematical Platonism, it's Plato. And so, and that way, much like being able to then to speak to the writings of Derrida and Husserl, instead of a person having to say like, I say so, they can say that Derrida says so, that Husserl says so, that Plato says so. and then that fulfills being this empiricist, pragmatist, correspondent theory of truth, while at the same time giving this nominalism, fictionalism, fallibilism to anybody, you know, in the sense of that otherwise it would be kind of improper to think that anybody could pick up that kind of burden themselves. To that it would be, it speaks to kind of the concept of the hubris or humility, where it's in many cultures it's important to not be like unhumble, to be too proud, because well, in some cultures it's considered a sin, or and that meaning a sense that it will deserve punishment and divine punishment. The idea is then as well is like it's just part of our discourse. It's just that humans are finite reasoning beings, finite creatures. So by thus understanding what is the surrounds, that is reasonable and rational. So in that sense, hubris is just related to rationality and a bit of skepticism. So reading here, looking for something profound. And maybe also when reading these courses, I try to read it through a generous lens of what I think would be right when talking about mathematical Platonism and strong logicist positivism. But it's important as well when trying to confirm one's own theory to look for things that stick out as wrong, because they need to be resolved. There can be no paradoxes. So, of course, the conscientious logician and mathematician in the wider growing theory, according to quantification and comprehension, once something else that's part of mathematics is there, it's always there, and it's enduring. And so then it becomes pretty important for a mathematical theory to resolve the mathematical paradoxes. The mathematical object seems to be the privileged example and most permanent thread guiding Husserl's reflection, the mathematical object. And to say privileged, that's like is P-R-I, primary. It means kind of first, and privileged is that's first communed or first held together. That's what I'd make of the roots of the word, that the etymology is the roots of the etymology's words, etymology. And so then for Husserl, for Derrida to say that Husserl says that these mathematical objects are primary in the theory, has that then they're also fundamental and elementary, and they aren't derived. And so the idea of definitions or statements is that they're defined, meaning a stipulation, asserting something is true, saying that it's an axiom, vis-a-vis derived, that derived means out of these other statements that are already given to be so for some reason, then it so follows that what's derived is also so. That here, saying that the mathematical objects are primary, and as well to be privileged in this theory of logicist positivism, has this extra kind of course that inside a weaker form of logicist positivism, when we're talking about things that are strongly mathematical Platonistic, so that would be necessarily some kind of stronger logicist positivism to arrive as true, then that's also kind of this notion here as with regards to Husserl's reflection. Husserl tries to accomplish a singular proof of these essential possibilities in connection with geometry, and to decipher therein the prescription of a general task. Here it's that it's just this axiomless natural deduction arrives at axiomless natural geometry, and that gives Euclid's geometries as derived instead of defined. And then where's the definitions that make up for this geometry and natural inference or a universe of these things? Those arise as from just kind of thinking about the things, and the inverse. So the inference and inverse together kind of make for that kind of thing. Which is why it's kind of special in foundations to say that, well, yeah, this is the only way we can arrive at something that's a strong mathematical Platonism and a strong logicist positivism, is to have that there's some axiomless natural deduction. that is true without anybody, any intersubjective being making any kind of stipulation or defining or declaring something as so, because there's none. And to make one would be its own, it would be a fallacy to make one, or it to be indefensible, unjustifiable. So that makes it, can still be a good theory. I mean, it's just any kind of putative theory is a positive sort of theory. But the idea that there is one at all for everything, and then makes for this kind of account of like, well, there's mathematical objects that are perfect. And as thinking beings and finite creatures, we may be imperfect, but we best and must well attain to these ideas of the perfect for there to be reason and rationality thoroughly. That this helps to reflect that just in this long discussion about this, with regards to Husserl and Derrida, that they're picking up the pieces that became all shattered after the idea that idealism was pushed aside and no longer existed, for then scientism and logicist positivism, briefly, for an empirical pragmatism, if you will, that neither one of those by themselves suffices. Yet there was just a rejection in the time, because before that it had been kind of like that the entire thing was top down, and so it was kind of top heavy. Yet now the idea is to make them balanced out in both sides of this teleology and ontology. And then as well, there's always, it's guided by this silver thread and continuity in time in history, thusly the teleology through and into the ontology. And then all the stuff about the human condition and inter-subjectivity in the world of fact, of earthly fact, are is related thoroughly these ways. The stronger mathematical Platonism, a strong Platonism is also strong. It's only mathematical, vis-a-vis the other ideas of what may be considered the immaterial, or that's those being super scientific, say. But the strongly mathematically Platonistic or Platonical or Platonic, and the stronger logicist positivism that happens to be science all the time, and is besides has all sorts of working models of any kind of theory at all that is good. So Derrida and Husserl are kind of helping bring this forward, and is like, while everything's shattered and we're making the foundations, be sure and keep perfect geometry, or else there's no guarantees at all left. So Derrida and Husserl at least speak to that. When they had to find one subject and topic that was like, we at least got to have this to have any kind of mathematical physics, and it was geometry, and so it's pretty cool. All right, so that helps explain a little bit more what's in play, and what's kind of discussed and turned over in the knockbout of Derrida with regards to Husserl. And I don't know too much of their other writings, and so I couldn't really comment if they have a bunch of different other ideas that it would be their own, and I wouldn't be able to necessarily relate to you, the reader, as something that I could say is like, well, it's intersubjective, and there's an account why it's interobjective, so you can take it or leave it, but at least there's some good reasons why you can establish for yourself all thoroughly that it's a matter of theoretical fact and a matter of thusly kind of not falsifiable, thusly verifiable, worldly, earthly fact. Besides that, then, the course of this is saying, well, at least throughout in this work, you can find a strong defense of mathematical Platonism and a strong defense of logicist positivism, and all in a kind of a constructive course. That's what's considered good about this, and why I just think so. If there is a birth of geometry for Kant, it seems to be only the extrinsic circumstance for the emergence of a truth, which is itself always already constituted for any factual consciousness. So on Kant, Derrida seems to suggest Platonism, and as well the emergence, as he puts it, the circumstance, well, he says extrinsic circumstance is vis-a-vis an intrinsic circumstance. So here the idea is it's more of an intrinsic circumstance than an extrinsic circumstance. as to why that then is related to matters of real truth, and as with regards to our subjective things that are considered to be matters of fact and true. But here, more about Kant, and Derrida quotes Kant. For he discovered that he must not follow the trace of what he saw in the figure or in the bare concept of that same figure. Rather, he must beget its object with the help of what he himself put into it and what a priori was representing it through the concept. And so this is saying that, well, we have a mathematical physics and we have like a science of mathematical objects in their perfect form as well. It's like, well, according to science, it's always been so that once it was established that the ratio of a circle's circumference to diameter was pi, then it's always so. A circle is a planar figure, a circle is equidistant at each point from its center, and a circle is thus mixed with the isoparametric theorem, these kinds of results, and it's also reflected up and down in the dimensions, and then here it's related to this the outside of a spiral space-filling curve, and that thus or a vortex, the reciprocal or inverse of that coming in from the outside of that Kant is saying as well is like, and now for just a perceptual being, kind of like a perceptor. Sometimes the neural networks they call a perceptron. That's anything that makes the light go on for a given reason. The perceptor, that their relation to that in mathematics and a model of mathematics to that is as well as some intersubjective fact. So at least Kant already gives it, well, yeah, all the facts of mathematics you can relay, and they're intersubjective even if they're not so themselves. True, that they're still facts, and we have a theory, and we use Euclid's theories for geometry, for example, and largely because it holds good. It's a good theory. That is still also true is another thing here. So Derrida is reading Kant is saying, because this is part of Kant's phenomenological side, and saying is like, I'm going to make my theory so you'll have to hear it in even if all you can do is listen and not think. So that's not really unusual, of course. And to know something a priori with complete security, he must attribute to things nothing but what necessarily followed from what he had put there himself in accordance with his concept. Then here the idea that axiomless natural deduction is like, it's there. And so that's always there, is the idea. No doubt, Derrida continues to say, Derrida, that was Kant. No doubt, once the geometrical concept has revealed its freedom with respect to empirical sensibility, so its freedom or its underpinning, it is foundational. So to say that that mathematics is free of empirical sensibility, because that has the problem that is reversed meanings here, because empirical sensibility means not wrong, and not the empirical sensibility meaning is like see rule 1. And so that's just kind of opposite here. But Derrida may be confronting that in a sense. No doubt, once the geometrical concept has revealed its freedom with respect to empirical sensibility, the synthesis of the construction is irreducible. And indeed, it is an ideal history. But it is the history of an operation and not of a founding. Here it is. There is a founding, so it's both of those. It unfolds explicative gestures in the space of a possibility already open to the geometer. The moment geometry is established as such, the moment, that is, something can be said of it, then geometry already will be on the point of being revealed to the consciousness of the first geometer, who is not in the origin proto-geometer, who is not as in the origin proto-geometer. So this is about our primitive geometry and our primeval geometry, our pre-geometric world, and this kind of thing. But who this first geometer is, though, is like a thinking being in that world. The primarily instituting urstiftende geometer. They're primarily instituting geometer. And so here that's just given to Plato. And then for whom he gives it is like Plato. At least it will be ready to be revealed in its initial concept, that concept whose a priori objectivity will presently strike any subject whatever with geometrical insight, the Lumiere. And since Kant is interested in the possibility of geometry for a subject in general, it is not only less constricting but also de jure necessary that in the de facto subject of such a revelation be anyone at all, and that the geometrical example serving as guide, the demonstration of the isosceles triangle, be indifferent. We have deconstructive accounts of mathematics, for example, as of geometry here. They kind of help build a bridge. It's like, well, this is the most deconstructive account, so it must derive from this nothing that composes to everything. That it's not so dissimilar for things like measuring the area of a triangle, and like as discussed a bit here, the measure problem, and how the invariance of measure is to be a thing and to be rational. That here then, just as with regards to that geometry is perfect, and that otherwise some of these facts, what I'm saying is that some of these facts that Derrida might be giving examples of truisms, and they're in the finite, so they're pretty much indisputable. Have it as well that there's ways to look at it as like, well, what about the isosceles triangle that's infinitely thin and infinitely tall? Or these kinds of aspects of, well, isn't that the same thing as this segment of a circle, as in the methods of exhaustion and it going around? Just making it so that when it gets back to, it's like, and this furthermore, this geometry will bring these natural infinities and natural continuities. And that the geometry example serving as guide, the demonstration of the isosceles triangle, be indifferent. The a priori nature of that concept within which we operate precludes all historical investigation, whatever about its subject matter. See, this gets into one of these things about the freedom of being able to be theoretical about anything, and to make any kind of theory and to entertain any kind of propositions as merely objects of deliberation and contemplation. And so when Derrida is saying is like, hey, in our logicist positivism, we might, for example, exclude in our later inductive accounts about the limit and standard linear curriculum something about this other side of it that's super classical to it, because then that would just give us nothing but a broken theory, because they didn't resolve all their logical and mathematical paradoxes, so something has to give from one of them to be the compromise theory in a sense. And so that's part of the milieu and the intermediate of these things with regards to theories together and their consistency, and good theories, and the ability to say to another logicist positivist is like, truthfully and according to everything I know, that this theory has nothing wrong with it at all. But he's saying that there's a given way to say that because I ignored this thing that disagreed with it, that here that's not considered part of this logical mathematical conscientiousness, which can't ignore anything, has to resolve everything. So that's also part of a strong logicist positivism as well, because there's always a greater abstract theory than one lacking that, where it falsifies the other side of it. So one of the problems of logicist positivism being, that one of the strengths is, take it or leave it, pick it up and put it down, take it or leave it. And that there's as well that this, like, people use it sometimes as like this or nothing, this or nothing, this or nothing, kind of an idea that or an understanding that's understated or underdefined, that are rejectable, that thusly it doesn't take a cynic or skeptic or somebody rejecting otherwise all these principles, rules, laws that go into reason to be able to reject something like that, a merely partial inductive account, as unjustified, as in regards to all the greater things and figures. Then where a lot of times the accounts of the objects in the logicist part of the positivism is that, well, I'm just going to make a rule, or my axiom, my positivist account is just that it works just like numbers, it works just like geometry, it works just like a particular kind of algebra. It's an arithmetization or geometrization or an algebraization. Using those models to equip these models, and thus they have all the strength and all the features and all the means of those. That's kind of like Boole's account. That I'll just say that in the time of Augustus De Morgan and George Boole, that Boole did a lot of things with regards to this kind of symbolic analysis and in this logicist positive setting, and then he'd use it to make great rules and say you can do arithmetizations things, but also to just make nonsensical things, and then just say that the numbers did it. Whereas Augustus De Morgan is like, we got propositions P and propositions Q, and all the laws with regards to P and Q and their mutual or not implication are defined. We did not have material implication here, only direct implication. So Augustus De Morgan's rules of symbolic logic then are about logic itself, vis-a-vis that Boole's arithmetizations and geometrizations and algebraizations are subject to the limits of when those have all their mathematical features. And so they don't necessarily need to be attached to these other inductive accounts. And then there's the idea that besides what Derrida says is like we have to ignore everything outside of our account. It's like you can impose those features of those objects of mathematics on anything else's account by those, and help to explain why either that gives or takes or holds, and it's both the same. So in this sense, adding two theories together doesn't necessarily, it results their union and intersection, not necessarily just their sum. So, but as well, it has on the outer side of that, their sum. So, in that sense, it's always the inner and the outer products of these complementary duals about resolving mathematical paradoxes and not having inductive impasses, which block reason and that make conscientious logicians and mathematicians unable to fulfill their conscientiousness, and thus given to reject that which so causes it. Well, that's about what we'll read from Derrida and Husserl today, and their great course is after Kant, and all these things about the empirical and geometry for Kant, and a scarcely altered conventional Platonism. Barring a scarcely altered conventional Platonism, Kant's indifference to empirical history is only legitimated from the moment that a more profound history has already created non-empirical objects. So here it's like, well, yeah, we got one of those for free. This history remains hidden for Kant. It can just be, it doesn't need one in logicist positivism. He can just bring the one that there is. If space and time were transcendental realities, a way would be open both for an ahistoric metaphysics and for a historicist empirical science, two interrelated possibilities that Kant always denounced in one and the same move. So here they're brought together instead, and it's said that Kant's Ding an sich and Kant's Sublime are it. So it's said that there's a subtext of Kant that, while at the same time he was making for logicist positivism on his own grounds for an individual's freedom of thought and religion and reasoning, that as well there can be one together. It's just not that there's no way to impose on it what must arise, be these stipulations and so on. So the axiomless, that there are no stipulations, that's the whole fundamental question of metaphysics bit, why there is that at all. So in that sense, Kant would have, he's saying that Kant answered the fundamental question of metaphysics in the negative, whereas here it's just like, it's the least amount of yes. To avoid empiricism from the start, and at any price, Kant had to confine his transcendental discourse to a world of ideal constituted objects, whose correlate was therefore itself a constituted subject. This notion of a proto-history, which the whole of Kantian philosophy seems to make contradictory even while invoking it, becomes Husserl's theme. So here it's considered not contradictory, and is considered necessary because it resolves all the other contradictions. So that's deemed agreeable. And it's in this kind of postmodern sense that's a really modern sense, and this postmodern sense that's a really structuralist sense, and this postmodern sense that's as of a text of all this canon and dogma, and so that it relates, and then it's subjective and objective, and then this is a technical setting. So then all such matters of opinion are basically excluded in the sense that there are none to make. And that the theory itself doesn't say anything about it except about its own objects and its own matters. So in that sense, then, for questions about the human condition more itself, is that, well, the human condition includes being a thinking being and a feeling being, and just because that's in accords to the phenomenological and this object sense, and that then the rest is individual and personal, the subjective to others, the objective of one's own. Then there's just to be kind of looking at some of these books here. This is kind of a course of what would get electron theory and nuclear theory of the 20th century kind of started. So this is Tinkham's group theory and quantum mechanics. And so it starts with a great account of algebra and group theory and the semi-simple groups and so on. They get so much into the applications of group theory about the properties of what result to Hamiltonians for the Schrodinger picture and Heisenberg picture of those, the regular representations. It gets in the representation theory of groups for given a mathematical model to a physical model and saying they're the same. So besides like a whole algebraization or arithmetization or geometrization, it's just like, well, the finite elements of a finite group can be like the parts of it, and so the mathematical model and the physical model are the same. When they are, that then anything that's a fact about the mathematical model just equips the physical model that's mathematical physics. So that's representation theory, briefly. And then with regards to that, and then some of its other conceits, it's like, and also then we're going to call them particles when they're points. And so we're to say they're particles, and so they're part of something, even though they're a point, and so they'd be a degenerate particle to be a point. And then mathematically, it's like, so with regards to the quasi and the pseudo, representation theory describes the great orthogonality theorem. If we consider all the inequivalent, irreducible, unitary representations of a group, then according to Kronecker deltas across three ways, that the sum of those up makes a ratio. Is just kind of a loose reading of something like that. That the fundamental theorems kind of help to affect or reflect that these are objects of true or anything. One of the key elements of these algebras, and there's all different kinds of algebras and magmas, is the group. And so there's an idea, it's like, well, is there a set of all sets? Yeah, in a set theory, maybe. Yeah, in a set theory. Is there a class of all classes? Yeah. How about a group of all groups? It's like, well, yeah, there is one. And I was so like if ORD is the order type of all ordinals, then GRP or group is the group of all groups. Well, what's its operation identity element, where its identity is either empty or universal, and then its composition is just adding the groups together? That this is just one of those things that makes for those being tractable. And then operator calculus is all about that. It's like, where are these group operations going to live? They live in the theory of groups, on all of them. These kinds of things. So Tinkham describes a lot of algebra, and then he gets into a lot of physics. So the first half of the book is algebra, and the second half of the book is physics. Brillouin zones. Here was mentioned Brillouin earlier with regards to like the Hunt processes and Hunt and what's those hockey skates? Hunt and Bauer. They in the non-standard probability distributions and these kinds of things. Brillouin zones. Heisenberg, Dirac, Van Vleck. That anyways, Tinkham then gets into a lot of different things with regards to group theory and quantum mechanics. This is the path integrals and quantum processes, and here it's similar. It has a bunch of mathematics to get up to like the Gaussian wave packets and Poincare invariance in the middle or so. Lorentz gauge expansions. The other day from reading about Duhamel principle and Lorentz is that I'm really thinking that Duhamel principle and the idea in the heat wave equation that there's something that considers it just kind of going along and generating as it goes along, that reduces to entropy all the time, and that makes the Lorentzian out of the Duhamel principle. And being that the Lorentzian is part and parcel of all of relativistic dynamics, I think that could be a pretty significant and central thing, is the Duhamel principle. Nuclear Theory by Robert Sachs, and it starts with these cool tables showing all the isotopes and how it's like, well, you know, the periodic table that makes kind of like all the periodic table, and it's got the bracket out by the electrons in the chemistry. It's like, well, the isotope table is pretty much like a straight line, and it's just kind of got stuff above and below it. So that's pretty remarkable. And he talks about the magnetic moment of the deuteron, and the monopole doesn't exist in this kind of thing. And again, this is mostly physics from the start, and then it gets into mathematics. Heisenberg. So if that one was Schrodinger, this one's about Heisenberg. In the coordinate setting, in the CM system. Scattering theory. So we've got scattering theory and tunneling theory. About Hadley, Kelly, Leith, Segre, Wiegand, and York. And Wallace. And Serber potentials. This is the nucleon theory. Russell Saunders. Magnetic quantum number. States. So this is just what it's going to be kind of being read as part of the 20th century physics. And this is for the unimolecular reactions. This is about chemistry and quantum chemistry. Because Slater gets into all the things that kind of go into the phase integration is kind of what's arrived at. The work of Laidler and Gill. A considerable set of vibrational analyses. Trying to figure out what there is of the ergodic and what happens when all the things all shake out. Kessel's method, the rate constants, the basis of transition state theory. This is chemistry. So. And then finally, Richardson's electron theory of matter. And so this is electron physics writ large. And as is discussed here, it's been looked into with regards to helping to explain why optical light is special, why optical light isn't necessarily electromagnetic, and all these kinds of things. Have a great day, gentle readers. Happy holidays. Warm regards.